Now let's practice writing out a Taylor polynomial. So we're going to take the Taylor of e to the x, and let's just remind ourselves, here's the equation of a Taylor polynomial, and it's just the value of the function at x naught, which is where we're centering it at, plus the first derivative at x naught over 1 factorial times x minus x naught, plus f double prime of x naught over 2 factorial times x minus x naught squared, plus f the third derivative of f at x naught over 3 factorial times x minus x naught cubed, and that goes on, and this is centered at x naught. So we want to evaluate e to the x, take the Taylor, and let's center it at 0. So what this is also called, when you're centering it at 0, it's also called a Maclaurin. So it's another vocab word. So the first thing we want to do is find these derivatives. So let's go ahead and write out some derivatives for e to the x. So first derivative is, well, e to the x derivative is just e to the x. Second derivative, once again, e to the x. Third derivative, also e to the x. And pretty much all of them are going to equal e to the x. So that's what's nice about writing a Taylor for e to the x. So now we know what x naught is, and we know the derivatives. So next, let's find the derivatives at x naught. So f prime of x naught, which is f prime of 0, is equal to e to the 0, which is just 1. F double prime of 0 is 1. F triple prime of 0 is 1. And that goes on. Let's just go ahead and write it like that. So now we have the values of the derivatives at x naught. We know what x naught is, and it's just a matter of plugging it in. So let's write t. That's going to be t for Taylor. So the value of our function, so remember, our function that we're looking at is e to the x. The value of our function at the center, which is 0, is just going to be e to the 0, which is 1, plus first derivative over 1 factorial is just 1 times x minus 0, so it's just going to be 1 over 1 factorial times x. I'm not going to write the minus 0 because that's unnecessary. Second derivative is 1 at x naught, which is 0, so we have 1 over 2 factorial times x minus 0, I guess, squared, plus 1 over, if we keep on doing that, x cubed, 1 over 3 factorial times x cubed. And, if you keep on going, you'll get these, and that'll go on forever and ever and ever. So let's write a general term. So we basically have 1s and x's on top, and we have factorials on the bottom, and the powers of x are increasing. And if you can see, the factorials are increasing by 1 each time, starting at 0. Remember, 0 factorial is 1. So on the bottom, we're going to have n factorial, and on the top, we're going to have x to the n. And this is one that you definitely are going to want to memorize for later chapters. Whenever you have e to the x, you can rewrite that as 1 plus x to the n. This is going to be our n equals 1, so 1 over n factorial, which is just 1. So 1 times x to the first over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial. That goes on till our general term. So yeah, you definitely want to memorize that. I guess you could just, x is sufficient over here. So it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And that goes on forever and ever.